Hey team, how are we going? Just give me a couple of minutes, just setting up a couple of things and then we'll get started. Sorry I'm a little bit late. Had my kids' football, so that kind of finished a little bit later than I thought. All right, differentiation. Yes, Watson, where are you? Come here. Jacob, I think this is... I'm under the education one, so I don't know how the ads actually work. Hey team, sorry. Let's set up the next chat as well. What are you guys doing? I've been here for like 3 years. All right, so what do we want to do? Differentiation. Do we want to jump straight into, start with a couple of achieved, or go straight into merits, or like, let's just go to the crazy excellence questions. By the way, this paper is from Cohia 2020. So I couldn't find an optimization in there, Ishmeet, but I guess I kind of found one. Okay, let's go one merit, and then we'll do one merit, one excellence, one merit, one excellence. All right. So, and I'll find like a nice crazy merit as well. So nothing too dramatic, not too crazy with the merits. Okay, give you a nice easy merit to start with. Oh, sorry, I need to fit this. And you know, sometimes people ask me, it's like, oh, how do I know which question to attempt and stuff like that? So sometimes you have to look at questions and you have to go, well, this is a good question for me to kind of do it in like a real quickly. That means you can actually get a fairly quick merit. So here we go. And level 3, I think you have 3 externals L Nova. I'm wondering, can you guys, oh yes, you can see that. That's, by the way, if you can't see that properly, that's x equals e to the power of 3t and y equals to t e to the power of t. All right, I'll give you folks another, maybe one more minute, and then I'll go through the answer. And in the meantime, I'll see if I can pick the first excellence question is quite nasty. Let me just do one more merit question, and then we'll do the crazy excellence question. Cohia 2020, Mikhail. Shaji, that's because there's a couple of rules you have to learn. I think once you learn the rule, this is actually not too bad. You got 2 point... Okay, let me have a look. It could be, but let me just... All right, let me have a look at it. So we've got... remember that we're trying to find the gradient when t is equal to 3. So in other words, it's actually asking for dy dx when t is equal to 3. So what you need to do is, firstly, remember that for parametric equation, you've got dy dx equals dt over dx multiplied by dy dt. So I need to work out what dx dt is first, because x is equal to 3et, I just write this here, because x is equal to e to the power of 3t, dx dt is going to be, I write everything as it is, e to the power of 3t. Then I'm going to multiply by the differentiation of whatever's in the power. In this case, that's going to be 3. When I've got y is equal to t e to the power of t, remember that this is actually, what do you call it? Product rule here. So we're going to write this as dy dt equals u dash v and uv dash. So I'm going to put u is equal to t. So u dash is 1. V is equal to e to the power of t. V dash, it ends up being the same, which is et. Raf, not as a tutorial at the moment. Yeah. I would, Adrian, follow that last person's advice there. Recommend watching that 15-hour playlist before you tune into the live streams. All right. So then dy dt is equal to u dash, which is just 1, times e to the power of t plus u, which happens to be t, and that's e to the power of t. So now all you have to do is just put dy dx. Now we've got dt over dx, so we need to rewrite this as dt over dx, which equals 1 over 3e 3t. So that's 1 over 3e 3t multiplied by dy dt, which is e to the power of t plus t e to the power of t. So I think if you... I think you would get an achieved if you were to do either this or get dy dt, which is this part here. But our question is actually asking find the gradient when t is equal to 3. Oi! What's it? Stop it! So then you got dy dx is 1 over 3 e to the power of 3 times 3 multiplied by e to the power of 3 plus 3e 3. Yeah, it's a tricky one there, Willie Sniper, because they just kind of put that in there and you don't even notice that it's actually a product rule. So at this point, I could write dy dx as 4e to the power of 3 divided by 3e to the power of 9. And you could actually write your answer like this if you want. You don't need to calculate it. You could actually write it as 4 over 3 e to the power of 6. And that answer is more than sufficient to actually get the merit grade for this. Wesley, some people say watch it at double speed. And they actually managed to watch it at 7.5. So yeah, Ishmeet, like I'm not actually going to work out the actual value of it, because in calculus, especially in differentiation, you can leave your answer in terms of E or ln. The reason why it's 4e3 at the top is because you've actually got 1. So then 1 and 3 makes 4. I'm glad you can join, Matt Pauling. What I might do is I might just put a couple of line numbers, just because if people are kind of going, where did... actually, wait, let's do this. 4, 5, 6, 7, 8, 9, 10. No worries, Millie, you're welcome. No, it's a tricky one, Ishmeet, because you're not actually given grades for learning how to simplify. But generally speaking, we like to simplify the answer. That's really important as well. So when do you know how to use the product rule is because notice how there's a t here, and this e to the power of t is also there. Now, if you were to write this, this would be written as t multiplied by e to the power of t. And because of that, it's that's how you know it's product rule, because it's actually getting multiplied. Confusion, you've got plenty of time. I think once you go through that 15-hour playlist, you'll definitely be ready for next year. No, Jackson, because you have those are two products. Because as Adrian is actually saying, it's like it's a polynomial and an exponential on the same line. We'll see, Matt, if whether it comes up in today's questions. What happened 11 to 12? What happened at 11 to 12? 11 to 12, I just substituted t equals to 3. Because in 11, it's the gradient function. 12 is where I substituted t equals to 3 and did that. No, Rhonda, I don't think that's... You're getting confused with a couple of different things, I think. Yeah, so the parametric equation, which is this one here, is given in your formula sheet, but really you wouldn't need it, because it's like whenever they give you two equations like this, you've got to differentiate both of them and combine it to get dy dx. All right, I'm going to do one more merit, and then we are going to go into a crazy excellence. I'm giving you plenty of warning. H of t. Just want to see how much steps and how much working this is. Oh, that's mean. Yeah, actually, this is not a bad question. Makes you think differently. All right, so next question that's coming up is a merit one, but I'm going to give you a couple of hints, because just so that we don't, otherwise you can end up in differentiation hell. So all right, let's try this one here. The clue that I'm going to give you guys is yeah, don't try to differentiate it without factorizing and rearranging the powers. That's all I'm going to tell you, the clue. Yeah, confusion, it can range from 7 sometimes, like sometimes it can be 8, depending on how crazy the paper is. I'll give you folks like maybe about 2 to 3 minutes for this, and then I'll go through it. That's correct, Jackson. You've got to do a double differentiation for this. Evian, it's from a paper from 2020 called Cohere paper. Just the Cohere papers tend to be generally a little bit crazy, is the right word to say. All right, like I said to you before, I hope you haven't actually tried to I mean, like this question here, it's asking for acceleration 3.2 seconds after it starts. So what you're looking for is acceleration after 3.2. So, Mikhail, I think, yeah, generally, but every now and then we do get some weird ones. So when you've got h of t, that's the vertical height. So you've got to work the vertical's velocity, and then you've got the acceleration. So you just got to differentiate this equation twice. Now the problem is this. When you have something like this, if you try to differentiate this by putting this as 1/3, you are going to end up with some really long, like you can actually make it into quite tedious for yourself. So really important to see, well, can you actually make this a little bit shorter and easier before you start differentiating. And if you look at the numbers, it's t squared minus 6t plus 9. So you could actually write this as t minus 2 squared to the power of 1/3. Because remember that t squared minus 6t plus 9, that's not 2, that should be 3, sorry. That factorizes to t minus 3 squared. Then what you can do is you can actually say h of t equals t minus 3. And if you remember the indices power, like the power rules, powers are powers, you just multiply the power. So that's going to be 2 times 1/3. So h of t equals t minus 3 to the power of 2 over 3. Now, differentiating this using chain rule is a lot easier than trying to do back in line 1. Line 5 is a lot easier to differentiate compared to line 1. So I'm going to differentiate line 5, which means I've got h over t, t minus 3 to the power of 2/3. So then the velocity is going to be 2/3 t minus 3 to the power of 1/3. And because you know how you have to multiply by the differentiation of this? In this case, it's just 1. So you don't really have to worry about it. So you can kind of go to the next one. Acceleration. Acceleration is going to be 2/3 multiplied by 1/3. T minus 3. Oh, that should be negative, sorry. That's my bad again. Yeah, negative. So I'm going to put my negative there. Negative 1/3. And it's going to end up being negative 4/3. And once again, we're going to multiply by the differentiation of this, which is just 1. So I guess in this question, it's actually much better to factorize and then kind of differentiate it. Otherwise, what happens is you're going to end up with like a really ugly product rule. And who was it that was asking before? Yeah, I can't remember who it was. But yeah, it kind of goes a little bit crazy. Okay, so let me just check if everything is good here. I've got 2 over negative 2 over 9. Yep, so that's my acceleration there. So my acceleration equation is equal to negative 2 over 9 t minus 3 negative 4 over 3. So now at this point, I need to find acceleration after 3.2 seconds. So I just substitute 3.2 as t. And I should get a value of something. Let me just work it out in the calculator. What do we got? Negative 2 over 9. So negative 2 over 9. And then that's going to be 0.2 because 3.2 minus 3 is 0.2 to the power of negative 4 over 3. Yeah, so it's around negative 1.9. And that's pretty much it for this question. So that's 6, 7, 8, 9, 10. And so in terms of achieved, I think if you get the velocity equation correct, you get an achieved. And if you get the final answer, you end up getting a merit. Evian, always leave it in radians. It's just easier. 3.2 take away 3 is 0.2. Units units are not required in differentiation, surprisingly, which is you don't need to worry about units. But if you do put units and you're like it'll be meter squared per second, or meter, yeah, is it meters? No, hang on, it's meters per second squared. Acceleration is always meters per second squared. Like, if you forget it, right, like, think about it like this. You've got your distance. If you ever forget your units, if you think about it like this, because your distance is going to be meters, velocity is distance over time, so that's going to be meters over second, and then acceleration is velocity over time, so that's meters per second over second, and that's how you get meters over second squared. All right, cool. So at this point, I am gonna kind of go into excellence questions. So folks, if you are kind of like, oh, I'm just here for achieved or merit questions, I would strongly recommend going back and having a look at some of the walkthrough exam questions, because I'm giving you a heads up. These next few excellence questions are they're gonna be horrible. But you know, we'll go through it, and then we'll actually see how that kind of works along. So the first excellence question that we're going to be doing is, and as I said to you, these are crazy questions. Some of you might find it easy, but just giving you a fair warning. Caitlin, this is live, but it gets saved in YouTube as well, so you can always watch it later. I did tell you guys it was asking. You asked for a crazy excellence. No, Evian, I hope not. But like, the reason why I do these kind of really tough questions is because you kind of get used to, like, doing these hard excellence questions. Like, look, you don't worry if you can't get these crazy questions, but what's important is that you try it. You'll probably make mistakes, and that's absolutely fine. And then I'll probably make mistakes too, but what happens is that it just teaches your brain the different types of strategies you could actually use for these questions. This is, yeah, definitely, it's rate of change. That's one thing we've got it right. Okay, so let's have a look at what the question's actually asking, all right? And maybe I might just give you a couple of hints there. So we've got two people that are walking next to each other, blah, blah, blah. Yep. And wanting to maintain a 2-meter distance. Maintain a 2-meter distance. How's that going to work? Their parts are 1.4 meters apart. And horizontal, the path, 1 point, horizontal distance between them. Like, this question is annoying because it's like, if you really think about it, it says they're wanting to maintain a 2-meter distance. But then where the question is asking at what rate is the angle between them increasing when they're 1.8 meters apart. So I think we can assume this thing here. So the 1.8 meters is that part there. Would you guys agree with that? Yeah, sorry, I'm just looking through the question, your guys' comments here. I think we're in the same time zone. Yeah. Okay, now I think like it's the question is like, if you look at it, it says at what rate is the angle between them increasing when they're 1.8 meters apart. So while they're wanting to maintain a 2-meter distance, I almost feel like that's useless information. So this part here is like useless information. I don't think we really need to use that anymore. Now, what it's asking is at what rate is the angle between them increasing when they're 1.8 meters apart. Now, if you look at the other thing, this diagram, I'm just going to draw it slightly different. Where this is your theta, this is 1.4 meters. Because the 1.4 meters is still the pathway. So you've got something like this, and let's say this is the yellow part here. All right, now, so that's just a rough idea of the diagram there. Now, what we know is the horizontal distance between them. That is dh dt. Yeah. Oh, so there it's really weird worded, eh? Because I think it's like the horizontal distance is the yellow part, I guess. Which means that if let's say I call this h, for example. If that's h, then dh dt is equal to 1.1 meters per second. All right, so we got dh dt. The question is asking what is d theta dt, because what rate is the angle between them increasing? So this is what the question's asking us. So all we really need to do is come up with an equation connecting. So we've got d theta dt equals to, we've got dh dt. So all we need to have here is multiply by d theta over dh. Because remember, d theta is in the numerator. So we need a d theta there. We've got a dt in the denominator. We already have a dt, so that's fine. But what we don't have is dh. So we've got to write an equation where we have to get rid of the dh. Now, if you look at the question, it actually says their paths are 1 point. So I need a different implement color. Right here, it says that their paths are 1.4 meters apart. So this is always going to be 1.4 meters. I guess what they should have said is like, instead of saying the word horizontal distance, I think they should have just said the word distance. Caitlin only did probability. Sorry, I've not done distributions. When this video finishes, I mean, you can always go watch it, start from the beginning on YouTube. Like, you can watch it now, but it gets saved as well. Okay, Palomason, you've asking me a really good question. How do I connect h and theta? Like, so I guess if you look at your triangle, you should be able to connect h and theta using just basic SOHCAHTOA. Yeah, well, yeah, I think sine theta is opposite over hypotenuse. Yep, there you go. Purple Panther's on the way there. So we've got sine theta equals opposite over hypotenuse. So sine theta is equal to opposite, which is 1.4. Hypotenuse is h. So I could rewrite this as h is equal to 1.4 over sine theta. So that's how you connect h and theta. Now, if you differentiate it, you should get dh d theta. Sol, I don't think I have space here to put. I don't know which part of the formula sheet that you're looking for. Alan Anthony, 100%. I would recommend you guys to do that. So he's asking, could you rewrite that as cosec theta? Yes. Otherwise, you're going to end up with a quotient rule, and it's going to be ugly. So we're going to write this as cosec theta. Now, Sophie, I think this particular question, I don't think they should have used horizontal distance. They should have actually used just distance, because the red part, which is the 1.4, that's going to be constant. That's always going to be, they're always going to be 1.4 meters apart. Like, there's a couple of words that's not perfect in this question where they kind of mess it up a little bit. Oh, what does cosec become? Okay, so you want that formula sheet. Sorry. Okay. Yeah, even I can't remember that one. That bloody, like, hang on. Level 3 formula sheet. Cosec goes into, I think I had it here. Let me just double check. Hang on. Where is it? Can't even find Zoom here anymore. Okay. Cosec goes into negative cosec cot x. Sorry, I should have realized that's the formula you're looking for. There we go. Simon, yes, the rate of change is actually in there. Yeah, actually, like, I think that's what I wanted to tell you guys. Like, while the questions actually look a bit crazy, this is actually one of these, once you figure out what the problem's actually asking, things will actually start to make sense a bit. Vishal, the way I remember it is like, for tan x, I do cot because of the t. For sine, I do the opposite of, so sine and sec don't match. So sine and cosec match. And then sec and cos match because of the C and S. That's how I know it's opposite of each other. That's how I remember it. Like the cot one, I remember it because tan is starting with a T and cot is over T. All right, so we're going to go from here, team, because we've actually got everything that we need. Or do we? Let me just double check. So dh d theta is going to be 1.4. Cosec x just multiplies to negative cosec theta cot theta. Now, when we actually put d theta over dt, we're going to get 1.1 multiplied by 1 divided by 1.4 negative cosec theta and cot theta. Now, the problem is we don't actually have theta. What we have is the yellow part, which is 1.8 meters apart. So we're looking at that point. So in other words, we need to go back to our sine rule because we need to figure out what theta is when this is 1.8 meters. So we're going to get sine theta is equal to 1.4 over 1.8. Then theta is equal to sine inverse of 1.4 over 1.8. Now, really, really important that we have the calculator mode in radians. So where's my calculator? We've got shift setup is in degrees, of course, because I was doing level 1. And we're going to go shift sine of 1.4 divided by 1.8. Basically, that gives me 0.8911. Now, the other thing also is in my calculator, I can't do cosec theta or cot theta. So I'm going to do this one more extra step here, which is 1.1 times. Now, negative cosec theta when it comes to the numerator will become negative sine theta. Cot theta will become tan theta. And the whole thing is divided by 1.4. So at this point, I can substitute theta in there. So I'm going to get 1.1 times negative sine 0.8911. And then I'm going to get tan of 0.8911. And the whole thing divided by 1.4. So I am going to get 2 sine. I feel like I've made a mistake somewhere here. Yeah, well, no, not 0.89, just 0.89. All right, let me just go through this. We've got 1.1 times, what do I have? Negative sine of answer. Tan of answer. That's the numerator. And then that's all equal to this divided by 1.4. Why am I getting negative? I should be getting a positive there. Now, Vishal, I just know that you've got to flip it and submit it. Kohia 2020 is the year. Yeah, that's exactly what I'm looking at, Matt. I'm wondering what have I made a mistake with that I'm getting this. DHD theta. What is 1.1? 1.1 is... here we go. I think I know where it is. It's negative 1.1. Thank you, confusion. Yeah, I was just looking at that. Because it actually says it's decreasing at a constant rate of 1.1. So if it's decreasing, that should be negative 1.1. Which means we should have negative 1.1, negative 1.1, and then that'll become a positive in the end. Nah, Jacob, it's so hard to kind of do both. Did I miss all of that? Yeah, okay. So, there we go. That's our question. Jacob doesn't feel it. He's like... That wasn't too bad, was it? That question was actually not bad at all. I mean, it's just the starting point. I think once we start the question, it seems to be a lot better. All right, let me know if there's any questions here. Can you put... Yeah, okay, I'll do that because I know people would always like to ask those questions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I'm going to go here, 11, 12, 13, 14, and then 15, 16. Jacob, I think that's a wording error. They shouldn't have said horizontal distance, because the horizontal distance is not going to decrease, because that 1.4 is always going to be the same. They, like I said at the start, they should have just said the distance between the two of them. I guess if you look at it from eagle eye perspective, then they could kind of say it as horizontal distance. Fayaz, you got to let me know which line number to kind of give you an idea. Confusion, are you actually on both chats? I missed it. When I start doing an excellence question, I try to not look at the chat because I get distracted. How do I go from line 9 to 10? So Simon, 9 to 10 is basically this. Negative cosec, like the cosec theta, when you bring to the numerator, it's just saying sine. Because remember, sine is 1 over cosec. And then when you have cot theta, so cot theta is 1 over tan and opposite. So tan is equal to 1 over cot. So basically that's all I did here. So those things came to the numerator and got changed to that. Daniel, I did see a comment on Instagram, and yes, there is a video coming out for that. There's going to be 2 parts to it, but yeah, it's something I might do after the break. Oh, is it on the formula sheet? I didn't know that. Is it? Where? Oh, it is too. Sorry. Yeah, guys, it's actually in the formula sheet as well. Apologies. I didn't even know there was. I forgot about that completely. Zombie, you'd be surprised. I think a majority of my audience have now got, like, some of my audience actually have kids, which is a bit scary. Yeah, this is definitely excellence. All right, give me a second. You might need to remind me because I can. Yeah, the setting up is always hard. All right, let's go to the next excellence question, because the next excellence question is another crazy one. I promised you a couple of crazy questions. But remember, it's all about setting up things and going from there. And I think there was a question like this a few years ago in one of the exam papers. I just can't remember for the life of me. I don't even know what you call it. I did up to step 10. Oh, step 10. V. I think all then you have to do is just get theta, and then you're good to go. Jenna, did you actually email me? Because I think somebody else asked me about 2015 question 2E. Let me just have a quick look at 2015 question 2E. That's 915782015. Ah, yeah, that one. That's a similar triangle one. I think we might be doing something very similar to that. But let's have a look at this next question. Next question is this one here. Yes, it's another excellence question. Yeah, sorry. I did see it somewhere. I just couldn't remember where. Give me 1 second, guys. I gotta put the dog. This is gonna be a fun question. Love a perfectly slim mirror. I think confusion, this is pretty much the same question here. Is this optimization? Would you call it optimization? I don't even know what you'd call this question. Would you call it would you call this optimization, guys? In a weird way, I guess. Yes. I don't know where to start. Okay, me neither. I don't know how to start this. Let's have a look through this. What do we got? I mean, look, let me put it this way. I feel like we're going to have to come up with some sort of equation, right? Okay, we're going to need an equation. This is not rate of change. That much we know. So we've got to come up with some sort of equation, differentiate it, put it equal to 0, and solve it. I think that's what we need to do. So if that's the case, let's have a look at this. How do we actually start this? When you're flat for start of university is a large mirror that's 3.5 long. To get to this room, Okay, why don't we do it like this? Why don't we create couple of triangles and start from there? Because I think if you look at it, you've got 1.3. What if we do it as like 2 triangles? Would that work? The hypotenuse has to be within 3.5 meters. I don't know. Yeah. Well, we're trying to figure out if the hypotenuse is going to be more than 3.5 meters. Or like, what's the biggest hypotenuse that can actually fit in there? I think that's the question, right? Like, if you think about it, the mirror is just the hypotenuse. And we want to know if we can create a right angle triangle and then prove that the hypotenuse is going to be, what's the maximum hypotenuse we can get? That's the question. That's literally what the question's asking here. The question of how we do it, now that's... What if we were to do it like this? What if we were to say something like, we had one triangle like this, and another triangle like this, and wouldn't this angle and this angle be the same? No, we can't have 2.5 as the max. That's cheating. So if that's the case, we now know we've actually got 1.3 hypotenuse 1 up to there. Then we've got 1.2 hypotenuse 2. And there we go. I think you guys can do this from this point onwards. Juntri, the 3.5 is, yeah, that's the mirror size. But what we're trying to figure out is what's the biggest distance the H1 and H2 can be, so that to see if the mirror is going to fit or not. V, I don't think it's about coming up in the mid-exam. I think that's part of the reason why we do these questions now, so you can kind of see different varieties of things that we could do. It's asking for the biggest distance. So H1 and H2, there's got to be a maximum. Frederica, I don't think we can do it separately. I think we have to write an equation together for that, right? You just have to add them and then you differentiate them. So basically what we're trying to figure out is this part here, which is the H. We want to know when is H max. So you're going to come up with an equation for H, which is H is equal to H1 plus H2. Then you're going to get dH. So you're going to get an equation and then differentiate, put it equal to 0 and solve for it. And I think you should be good with that. Can H1 be 3.5? No. Matt Pauling, it cannot be because we don't know what the maximum distance for that yellow part is. We don't know what the maximum distance is, so we can't assume that it's going to be 3.5 exactly. But what we are trying to find is what is the maximum distance for the yellow part. Then we can see whether 3.5 will fit in there or not. It's lots of practice, Mr. Instigator, but I think it's also learning. Like, I've not done this question before. And so the way I looked at it was like, well, it's not a rate of change question. It's not like a shape within a shape question. Well, kind of it is, because you've got this. And then I was like, well, what else can I do? I can create this as two triangles with a hypotenuse. And so that's how I kind of started from. 100% you've got to use trig for this, Ashley. You could say y plus 1.2 squared. Where'd you get the 1? Yeah, Jacob, that's another interesting way of doing it. I think I know what you're trying to say. All right, so I'm going to start doing this one. No, you don't sub 3.5 at all. 3.5 is you're trying to figure out if the yellow line is going to be more than 3.5. All right, so let me show you guys. So firstly, we've got two triangles, right? I am going to figure out how to do this. So this is going to be the orange triangle, and then we're going to get the pink triangle here. So first, I'm going to look at the orange triangle, then I'm going to look at the pink triangle. So that's the pink triangle, and that's the orange triangle. Now with the orange triangle, we've actually got 1.3, we've got H1, and then we've got theta there. With the pink triangle, we've got H2, we've got 1.2, and then theta there. What we're trying to figure out is the H, which is H1 plus H2, because that's the full length of H. So if we look at it, we need a formula for H1. So for H1, that is using opposite and hypotenuse. This is using adjacent and hypotenuse. So you're going to get sine theta equals 1.3 over H1. Now if I cross multiply, I'm going to get H1 is equal to 1.3 over sine theta. Sine theta is, well, I'm going to do the exact same thing as I did the last one. So this will become cosec theta. And on this side, I've got cos theta equals adjacent over hypotenuse. And then H2 equals 1.2 over cos theta. H2 is 1.2 sec theta. So in other words, my formula for the H is H1 plus H2, which is going to give me 1.3 cosec theta plus 1.2 sec theta. And what I'm going to do is I'm going to pause there for a second, because just want to make sure people are on the right track. Now look, even if you get up to this point here, you will probably, setting up the equation generally does not give you achieved for optimization. You've got to differentiate it at some point to get a merit at least. Instigator, yes, it's using SOHCAHTOA. Isn't theta 45? No, theta is not 45. We can't assume what theta is, Ashley, because remember that theta is constantly changing. because as they bring the mirror around, the angle is always going to be changing. Yeah, so now that we've got H equation, you just differentiate it, put it equal to 0, solve for theta, and then go back in the original one and figure out what it is. So Paulo, to find theta, you got to differentiate H. You get H dash, and then put it equal to 0. Well, Ben, once we figure out what the maximum distance is, we will know whether this mirror is going to fit or not fit at all. Because that's the whole point. We're trying to figure out what the maximum distance for H is. And I think that will give us an idea of whether this mirror is going to fit or not. So we got to find theta, then we find H, then we can actually see whether this works or not. Hang on, I'm just going to move the formula sheet. There you go, formula sheet's there. Tootflesh, I love what you're saying there, but unfortunately, I don't know what you're saying there, and it's a bit, I'm not sure if you need help or not. I'm hoping it's a lovely story, Twitflash, but yeah. If it's a question, I'm sorry, I'm not able to help you yet. I started learning at Confusion, and then I got distracted. It's all right, Twitflash. You're allowed to speak that, but I mean, I've got no issues. It's better than some of the rubbish we get here every now and then. Yes, that's correct, Juntri. That's absolutely right. Okay, I'm going to do the H dash now because I think you guys are good here so far. So if you do H dash, which is, by the way, here's another thing that I want to let you guys know about excellence questions, right? Sometimes you can come up with the wrong equation, but if your differentiation is correct, there is a possibility you might even get like a merit grade because it's a minor error. So when you get the optimization questions, just give it a full go, and then we can see what happens. All right, so I'm going to differentiate 1.3 cosec theta, which is going to be negative 1.3 cosec theta, cot theta, and then 1.2 sec theta is going to become 1.2 sec theta and tan theta. My God, this is an ugly equation. So our max happens when H dash, yep, that's correct, Ben. Our max happens when H dash is equal to 0. So we're going to put this equal to 0, negative 1.3 cosec theta, cot theta, plus 1.2 sec theta, tan theta. Oh my Lord. Now looking at this actually looks kind of like super crazy, but I want you guys to know this. If you actually Mikkel, that's actually from right here. You can see the cosec theta here and sec theta here. That's what I did. We are setting it to 0 mean because we're setting it to 0 right now. But while this looks kind of ugly, I promise you this actually works out real nicely, because all you have to do is get rid of all the cosec and cot, replace it with sine, tan, cos, whatever. Remember, cot is 1 over tan, and tan is actually sine over cos. So I'm just going to do this. I'm going to take negative 1.3 to the other side. I'm going to write 1.3 cosec theta cot theta equals 1.2 sec theta tan theta. Now, what else can I do here? Sec theta cot theta. I could get rid of... No, I can't. So I'm going to rewrite this. So this is going to be 1.3 1 over sine theta times 1 over tan theta equals 1.2 1 over cos theta multiplied by sine theta over cos theta. And going one more time, I've got 1.3 1 over sine theta times cos theta over sine theta. 1.2, I'm going to get sine squared theta over, not sine squared, just sine theta, cos squared theta. Then on this, I'm going to run out of space. I've got 1.3 cos theta over sine squared theta equals 1.2 sine theta over cos squared theta. Cross multiply is I'm going to get 1.3 cos squared theta, no, cos cubed equals 1.2 sine cubed theta. Then I'm going to go 1.3 divided by 1.2 is sine cubed theta over cos cubed theta. Then I'm going to get tan cubed theta is 1.3 over 1.2. Then keep going. Tan theta is 1.3 divided by 1.2 cube root. Then theta is equal to inverse tan of cube root 1.3 over 1.2. Like I told you, it is a long question, but it does work out really nice at the end. So we've got inverse tan of cube root. So 3 that cube root of 1.3 divided by 1.2. So your theta is equal to 0.798. Sorry, I didn't read through the conversations there. Simon, yeah, this is not an E9 question. This is just a E8. Tomorrow, Paulo, we do integration tomorrow. By the way, we're not. I'm sorry to say this, we're not finished because we still need to find whether this stupid mirror is going to go around or not. So we need to go find what H is. So from here, we're going to come back. Remember, H is equal to 1.3 cosec theta. I'm going to write it as 1 over sine theta plus 1.2 1 over cos theta. So theta is 0.798. I'm going to substitute it in. Like, you know, it comes to a point where you just don't have enough space anymore. Sine 0.798 plus 1.2 over cos 0.798. That is going to give me the answer I'm looking for. So this is 1.3 divided by sine of the answer plus 1.2 divided by cos of the answer. There we go, team. We're getting H is equal to 3.534. Yes, mirror will fit. Sorry, Simon, what did I miss? I asked him before. Yeah, it's on the formula sheet. Yeah, so they can fit that mirror with like 4 centimeters spare. All right, let me put some line numbers here. And I'm so sorry. I know some of you might not be able to see this. 18, 19, 20, 21, 22, 23. Eight tomorrow, Ben. 8. Optimization is always about finding min or max. You got it negative. Actually, Matt Pauling has got a very interesting suggestion. Thanks, Matt. We're gonna try it out, because Matt's suggestion was, why do we do all this working? Why can't we just do it in there? So 0.78 was our answer. Let me just see what happens if we do that. Let's go to equation. We're gonna go to solver. Where's my h dash? Oh, that's that ugly looking thing. Okay. So I've got negative 1.3. That's cosec theta cot theta. So that's going to be divided by, cosec is sine theta, so sine x. Cot is tan, so tan x. Negative 1.3 plus 1.2. So 1.2. And in the denominator, I'm going to have sec theta, which is cos, oh no, wait, 1.2 tan theta, actually. Tan x. And then in the denominator, I'm going to have cos x. If this works, Matt, you will be a legend. Come on. Equal to 0.798. Solve. Where's my answer? Why am I getting this answer? Matt, did it work for you? Because it's not working for me. I'm getting 751. Brackets? I don't think brackets, unless I did something wrong. Hang on. Tan theta. Cosec. Oh, wait. Cot, sine. Are you just trolling me, Matt? I'm trying to look sine theta times. Okay, wait. What if I just put a times there? Would that help? Let me try times here and see if that makes a difference. Sine x is cosec. Yeah, that all looks good. Nah, it's not working. Sorry, Matt. No, it's not working. Okay, so I guess that's not going to... I think it's because... Let me just try this to see if this works. If I just do sine x... let's just go sine x equals to... Cos x equals to 0. Let's try that. Yeah, nah. It's not going to work. I think it doesn't like trig, because we know cos x equals 0 is not 752. Press AC twice. No, that's not working. Nah, it's all right. Okay. Any other questions with this one? While Orozo, yeah, so there are multiple local mins and max. Am I taking largest? Yeah, I think so. Yeah, I agree. Because it will have like, because it's a repeating curve. Because if you think about it, like, yeah, so let's not worry about it. V, I think it's about just kind of having a look at these types of questions, and as you do more of them, you just get like little ideas. Now, like, look, the reason for me, like when I did this question the first time, today is the first time I've done this question, but I've done so many of these questions, and because I've done these questions like different types, I'm just like, well, what are they trying to ask? I always try and go, what are they trying to look for? What's the information that's been given, and how do I connect that? That's how I do these excellence questions. What's being asked? What's given? How do I connect those two things? Team, what we're going to do is we've got one more. Do you want to do one more crazy excellence question, or do you want to call it for a night? Lewis, it's incredible you asked that question, because the next crazy question is about concave up and concave down, but in such a different way. Let me just check. All right, let me just check how to get this one up and going. So concave up. Okay, we've got another excellence question, which is going to be about concave. Think of the ad revenue. You know, the ad revenue is what I use to buy your guys t-shirts, to give it away for free. All right, let's do one more. I'll give you a nice excellence question. And I think you've already done, this is the start of the previous, so we did do this question earlier. So let me just rearrange a couple of things. So just so that it makes it easier for you guys. Okay, so here is the question. We did this earlier at the start of the session, which was a merit question that we did. Now it's just going to have a follow-up question to it, which is an excellence question. And what you're asked to do is to describe the concavity. So you're looking for, when is it going to be concave up and when is it going to be concave down? And also, one thing that's going to be useful for you is this particular information, which I'll actually paste for you, because for parametric equations, remember that the formula is slightly different when you're doing second derivative. Okay, sorry, I missed a few questions. It is a parametric. Yep. Please be parametric. These are all from past papers, Bianca. Yeah, some of these old papers that I've got access to. No, Juntri, because for concavity, for concave up, it's negative, and then for concave down, it's positive. So your F double dash has to be less than less than 0, because for a concave up, because concave up means it's a max. So remember, we used to do this like F double dash is greater than 0 means it's a minimum. So that looks like that. If F double dash is less than 0, it's a max. That looks like that. So this is how I know it's up, and this is down. Cura, Oliver Cura. If double diff is positive, it's up, yes. So you just got a double diff. But the thing with double diff in this case is that you've got, because it's parametric equations, you've got to use the formula in the blue box which is actually in the formula sheet. So this formula comes in the formula sheet and you have to use it. And I think we have done part A like in earlier in this question. So Sarah, if you look at the top, this should tell you when my level 1s are coming. Ben, yep, that's correct. Yeah, sorry, I missed your comment there. Kool-Aid Man, 100% you can do that. That's not recommended, but there's nothing that says you can't do it as well. Now, Simon, you give it a go. I think you see how far you go. I'll give you guys maybe another couple of minutes and then I'll answer the question. Yeah, Bob, you've got it. That's pretty much it. Problem is you've got a dy dx, which is a quotient rule, so you've got to use quotient rule. Ben, I picked up like I picked up like 3 tubs of ice cream, and I've hidden one in the big freezer in the garage, and one in the normal freezer. I understand stress eating, my friend, because I'm no, Simba, you cannot give up. Come on, everything's there for you, okay? But here is dy dx. I think we already got dy dx. Did we simplify dy dx? I got a different question here. What did you guys get for dy dx? Like, I'm just looking at t plus 1. Oh, yeah. That makes sense. Yeah. So here's dy dx, by the way. That's in line 11 as Jacob mentioned. We did this earlier because dy dx is equal to, we've got et plus TET divided by 3E3T. Now, ET is a common factor in the numerator, so I'm going to take it out, which means I'm going to get 1 plus T divided by 3E3T. I mean, you didn't have to, man, but thank you, but you didn't really have to. So the next part is we can write this as 1 plus T over 3E2T. So this is what dy dx is. Once we've got dy dx, if we want to differentiate this, so if you look at the formula here, we've got this green part, we've actually got to differentiate dy dx with respect to dt. So that means I need to take dy dx here. This is going to be 1 plus t over 3e2t. Now I need to use quotient rule for this. So u is going to be 1 plus t, v is going to be 3e2t, u dash is going to be just 1, v dash is going to be 3e2t multiplied by differentiation of the power, which is 2. So v dash is equal to 6e2t. That's pretty much one thing of it. So if we're going to say differentiation of dy dx over dt, this is u dash v minus uv dash over v squared. So we're going to end up with 3e2t minus 1 plus t times 6e2t, and the whole thing is divided by v squared, which is 3e2 2t squared. I'm going to simplify this because I have to, otherwise it's just a bit messy. So I've got 3e2t minus 6e2t plus t times 6e2t. And the whole thing is divided by 9 e to the power of 4t. I don't know why I did it that way, but like I could just move this all here. All right, I'm going to pause there. Let me know if there's any questions, issues. 1, 2, 3, 4, 5, 6, 7, 8, 9. I still haven't actually done the things put together, but I might just do one more step with number 9. So step 10 would be, I could put that as -3 if I wanted to. Yeah, let's do that. No, wait. I don't want to stuff it up here. 6et, -6et. Oh, and I forgot minus t. That should be minus there, not plus. Eventually we're going to do that. I'm just checking that I haven't actually done any mistakes here. I've got -3e2t plus t6e2t over 9e4t. That's actually step 10. So now I want to do the double differentiation. So the double differentiation formula, I write it down. Over dx is d of dy dx over dt times dt over dx. So I've got -3e2t plus t6e2t over 9e4t. Now dx dt, I think I had it from my previous question. That was just, or dt over dx. I'm getting it from here, which is going to be 1 over 3e3t. Where did I miss the negative? Keep stuffing that, man. Oh, Lord. Okay, yeah, you guys are right. That should be negative there. Yeah, Ishmeet, that is correct. All right, nearly there. What do we got? We can take 3 as a common factor, e2t as a common factor. So I'm going to get 3e2t. That's going to be -1 minus 2t over 9e4t multiplied by 3e3t. So I can cancel this and this, cancel 2t, leave it with 1t. So I'm going to end up with -1 minus 2t is 9e5t. And again, I'm going to pause here. Let me know if you have any questions. Sorry, Bianca, I think you've got to ask that question again. Just let me know which line number you're looking at. Yeah, Ashley, for one of your answers, it's that. Because remember, it's asking for concavity, which means you got to do for concave up as well as concave down. But you already got the answer. The other one would be, one of them is concave up and one of them is concave down. What's happening in line 11 is basically, it's just this, just the formula there that I've just written it slightly bigger. So Ashley, you know how you find t greater than -12? So I think for that one you put, did you put greater than 0 or less than 0? The blue box is the parametric double differentiation equation because that comes in your formula sheet. Let me find it. So that's what's from the blue box. So question D, we did this. Question E, we're actually doing this. It's just slightly different way of writing it, that's all. That's all I've done in the blue box. That's the formula that I've used. Because when you do double differentiation for parametric equations or functions, you've got to use this set of formulas here. Lewis, I mean, like that's, I think I just explained that. It's just the same. Blue box is just from the formula sheet. That's all. Correct, Ishmeet. In line 11, this part here is the same thing as saying that ray. That's the same, that red part is just another way of writing it. Maybe that's where the confusion's coming from. Sorry, team. Correct, Bianca. You differentiate it, and then you've got to multiply it with the dt dx to get the second derivative. Yes, Ziba Hussein, because like, remember, this is, I've simplified it here in line 3. Savindu, check my YouTube channel for prob videos. Correct, Ashley, but you got to say which one is which. Right, team. Now, we've done the double differentiation. So remember, we had the thing where f double dash. So f double dash has to be greater than 0 for concave up. F double dash has to be less than 0 for concave down. So, in other words, we've got -1 minus 2t over 9e 5t has to be greater than 0 for concave up. -1 minus 2t over 9e 5t has to be less than 0 for concave down. So when we take the denominator to the other side and multiply by 0, we're going to get -1 minus 2t is greater than 0. Rearrange this. -2t is greater than +1. And finally, because we're dividing by a negative number, we need to change the symbol. And this would become 1 over -2, or t is -1 over 2. Likewise in here, -1 minus 2t is less than 0. -2t is less than +1. T has to be greater than, because we're dividing by a negative number. So t has to be greater than -1 over 2. So pretty much that's what you need to do to show that it's concave up and concave down. So you actually have to take the double differentiation and you have to solve it. And so Ashley, if you just write down those two parts, it's not enough. You have to specify that for this t less than -1/2, it's going to be concave up. For t greater than -1/2, it's going to be concave down. Because that's going to be your E8 right there. If you don't actually mention that, you're going to end up with an E7, which is quite horrible. Line 7, why doesn't using the quotient rule not give that? No, because Gideon, the line 7 part is just for the green part of the parametric equation in the blue box. So if you look at it, parametric equation, there's two parts to it. So the orange part, which we did in the previous question, the green part, just that first part is everything here. So this is the green part that we got from here. So that you're not double differentiating there, you're just differentiating it with respect to t. Hamish, absolutely. You can jump on YouTube and rewind and watch it from about 9:30 when I started this question. I don't think I can do a quick recap of this. Simba, yes, that's correct. Line 11, that whole, the two things that you're talking about is the same thing. Because Gideon, it's a fraction, and when we actually differentiate a fraction, we have to use quotient rule. The arrows, Evian, like inequalities, whenever you divide by a negative number, you need to change the symbol. Sorry, Faizan, I know you been wanting a shout out for a while, but it's just, I've just been trying to get through the questions, man. So there you go. Got your shout out. Parametric equation on the formula sheet is here. So it's usually in, like, the page 2, right at the bottom there, you're going to see the parametric function formulas. Blake, the dt dx is from the previous question. We did it right at the start. So you can jump on YouTube and watch the replay from the beginning, because that's the first question that we did today. Sam, I know people have been asking, like, honestly, I am terrible. I've not learned how to do triangle or rectangular distribution. So I don't know. I can't recognize it. I know binomial, Poisson, and normal, but not as the other ones. F double dash of x equals 0, Juntri, that's usually a considered point of inflection. So now tomorrow we do so spades, like, if you ever forget it, like, think about it like this. It's like, you know how you have minimum points and maximum points? So I always write like this: if f of x is greater than 0, that's a minimum. Now, when I say minimum, you think about a parabola that has a minimum. So that's u. That also means I use that u shape as up. That's how I remember. And if f double dash of x is less than 0, that's a maximum point. And that looks like, the upside down umbrella, like that. I call it upside down umbrella. So it's like down. That's how I remember it, as concave down. Yeah, integration is tomorrow, team. Nah, Citizen, I think I'm done, man. Like, I did, like, it's been a long day, and I think we did like 1.5 hours of excellence questions. So are there fixed amount of possible? Yeah, Kool-Aid man, it'll always be 3 excellence. Usually it's the question E that's an excellence question at level 3, especially calculus. So it kind of works out nicely. Yeah, there you go. Concave down, you're sad, you're unhappy. Concave up, you're happy, which means the graph is pointing up. Speedrunning achieved questions. What are we going to do? Like, do we want to do a speedrun of achieved questions? No, I think Ishmael, they always do 1E question. It's on the odd occasion they do I think you guys can do speedrun achieved questions on your own. It's like, you wouldn't need me for that. I'll see if I can find some, like, any kind of weird achieved questions. Nah, they're all these papers. The achieved questions are long. I hate the achieved questions in this because they actually make you do so much work. Yeah, nah. I think we'll call it Daniel. But tomorrow we'll do integration. Now, look, I've got to ask you guys a serious question. On Sunday, like, because Sunday night, I think, is it better for you guys to go do some independent work by yourself? because I don't know what should I do on Sunday, because we did complex yesterday, we did differentiation today. I mean, we can do again these crazy questions on integration tomorrow. What do you guys want to do on Sunday? Or do you just want to study on your own on Sunday? So I don't disturb you people. Now, if not, then I might actually try and attempt distributions, for the love of God, because it's just, I feel so bad for so many kids that have asked distribution questions for stats. Now, Jacob, open tutorial session always go crazy, because it's the problem with open tutorials, like you get everyone coming in, and it can be a little bit crazy, because some people want to just get achieved, some people want to get merit. Ishveet, like, look, that's part of the reason why I don't do answers straight away, because otherwise it just kind of messes up with people's other exams. 8 p.m. guys, I think 8 p.m. is when all the live streams would be. And Dark Flame, yeah, Mikhail is on the money there. Physics and calculus mainly. All right, cool team. I think that's us today. Yeah, just struggling to stay focused here. I think total solo revision. Yeah, let's do Sunday solo revision. You guys do it on your own. I might be running just probability or a distributions one. I'll have a quick look just to see if I can do like a speed run of it, just whatever I know how to do, and then go from that. I mean, most of the guys know how to do these questions anyway, so yeah. But I will see you guys tomorrow for integration. And if we finish, like, I think tomorrow we might go a little bit longer. We'll do like integration for like maybe an hour and a half. And if you guys are still up for it, then we can do a bunch of a few more excellence questions if you want to take a break. And then just, I'll get like tomorrow afternoon, I'll get a good sleep. So knowing that we'll do some work later in the evening. Tanik. 8 o'clock tomorrow, team. 8 o'clock tomorrow for integration. Yeah, we'll do integration for 1.5 hours. And then after that, as I think, what was it? Not Jacob. As Jacob said, we can actually do some open. I'll see if I can find some more crazier questions from like just random places, and we can do it. I love that, Ishmeet. Like, I would love for you guys at the end of this to write up some reviews for the level, the 15-hour playlist, because it was such a simple little concept that we came up with a few years ago, and it just, I'm glad it's helping so many people. Nah, Thorfinn, I still haven't had a look, because I'm a full-time teacher, and it's like busy, man, busy. Willie Sniper. Come on, man. You guys have like 7 weeks or 8 weeks to learn that. I cut that to 15 hours, and then now you want me to cut into... Now, what? Next thing you're gonna be like, sir, can you make this into 15-second TikTok reels? Oh, Maisha. I'm glad you're using them, Maisha. I'm trying to think. Did I visit last year or like this year for Green Bay? How long has it been? Willy Sniper, I've heard people watch it on double speed to catch up with it. There you go. V's saying the same thing. Tainik, honestly, like, look, I'll be honest with you guys. Like right now, let me show you this. Social blade. Where's my social blade? I'll show you this, right? Where is it? Where is it? Video stats. All right, here's something to show you folks. If for some reason, live streaming YouTube, where is it gone? Damn it. Add source. Here we go. Like this is the whole year. Like you look at this is the whole year. Nothing, 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 nothing. And then you look at September, that's the box. And then you look at earlier in this week. If I get that many views, then yes, I can definitely do what do you call it? 15-second reels. But otherwise it's like, nah, I can't do that. I know, right? Like I'm only like in New Zealand I'm ranked 168, but that's because I'll show you this. Like I'm at 68.33 subs. So I think it's because it's like how long people watch it. Adrian, a few years ago I would have said I probably would be a teacher for a very long time. Now I'm thinking I would love to be like a part-time teacher and full-time maths content creator. Yeah, V, that's been in my plan. In fact, if you guys want to, I'll show you one other thing that's actually quite handy. If you're just looking for excellence questions, then you could always do this. What I have done is I've created this on my webpage, which I do not maintain, by the way. But in level 3, if you go to complex numbers, and if you go to NCA exams, you should be able to just click on the E questions right there. And I think it goes all the way to 2017. We've tried and linked as many of the E questions there. So if you do want to practice just E or achieved questions, you can always do the speedrun version here. Yeah, so that should have all. I can't remember if I updated integration yet, but yeah, those are there as a shortcut. So if you just click on the E ones, it just takes you directly to those questions and you can just work on them. Yeah, I had some people help me out with it, and then that way you can just do that way. Sorry, I completely forgot about this one. Nothing, Hamish. I would probably do everyone. Yeah, pretty much, Thorfinn. That was what I was trying to set up, but I haven't, like, I don't think I've advertised it very well. So if you want to go to, like, say, you know, integration question 3E, you're stuck on it, click on it, and then that should take you straight to that question, and then you should be good to go. What did we miss? Mikhail, I think if you just look up Infinity Plus One website, you should be able to find it. If not, it's on my YouTube channel, or I don't know if I put it up on TikTok anywhere. Oh, right. Okay. I thought so. I thought you were year 12. Citizen, not really. I mean, if I'm a successful YouTuber, I would be doing it full time. I mean, like, it's taken me, I've run this channel for 12 years and I still haven't cracked 100K. So, you know, I don't think I'd call it. I don't think I'm in any position to give advice here. The how to excellence video, Pine. Yeah, that's not a bad idea. But I think I need to make Daniel Hyde's question, his video first. No, Mohammed, sorry, I've not set it up yet. Nah, of course, Thorfinn, I understand that. Like, theoretically, I'm not supposed to have this many subscribers because I think at any given point, you get people that'll, they use it for 3 years and then they're done. They finish. They don't need to use the channel. But it's really nice when, I always say to people, like, stay subscribed, but switch off all the notifications. Because, they would always, it's always nice when people come back like years down the track. Like I've had so many people come back. I did this in 2017 and 18 and still good to see going here. Why, Daniel? Why is it such a big deal? Nah, Tanik, year 11s are on Thursday. Shot, Mikael, appreciate it. Parthiv? Nah, I would say nothing is impossible. And you put your mind into it, you can do whatever you want. Nah, Lemmy, that's not my territory. Physics is Mr. Weebly's. All right, cool. Team, look, it's 10 o'clock. Shadai, I got to do a few things so I can get some sleep. And then we'll come back tomorrow at 8 o'clock for integration. And then what we'll do is do a few questions, as usual, crazy questions. And then we'll see if we have time to do some more crazy questions from like different topics. But yeah, awesome. Thank you so much, TikTok. I will see you tomorrow at 8 p.m. If you, by the way, TikTok, if you do want to watch the replay of this video, it's on YouTube. So just jump on and you'll find it in the live section. But yeah, take care. Good luck and keep practicing. That's all I can say. So see you tomorrow, TikTok. And that ends it. YouTube, thank you so much for being here. But yeah, keep practicing and I'll see you guys tomorrow for integration tutorial. All right. We'll definitely do some differential equations. That should be good fun. All right, team, take care. As always, thank you for watching. See you.